Welcome back. In combining functions, there's one more operation we haven't talked about, and that is called function composition. And so you can see the formal definition here. The notation that accompanies it is this circle notation. So be on the lookout. It is not, so F circle G is not the same as F with a solid dot G. The open dot is very significant, okay? Because what we're doing with function composition is if we're doing F of we say this is of f of g of x. What we're doing, and you can see it here, g is going into f. So g of x is the input into f of x. So we're putting a function into a function. Okay, that's why we call it function composition. Okay. The algebra, the arithmetic, once we kind of get it down, not too bad. Okay. The domain, this can be a little tricky, so please take your time with it and ask lots of questions. The domain of f, here's the formal definition, okay? There's two things we need to pay attention to. Is a set of real numbers of x that is in G, okay? So we need to find domain of G first, okay? And this last bit, G of x is in the domain of f. Now, I kind of cheat and I do the composition first, and then I find the domain of that composition, and then I intersect them, okay? Whatever you get from that intersection is going to be the domain of your composed function, okay? The reason for this is whatever we put into the function, we have to make sure that that's defined first, right? So hence the domain of G, and then whatever we get out, domain of f of G of x, that needs to be defined as well, okay? So with the domain of a composition, look for two things, okay? Let's see an example, okay? We'll go through some of the arithmetic and algebra first, okay? Just so we have a feel of how this thing works algebraically. F of G of 2, okay? Again, what this is saying by definition is F, and then inside of F, we're doing G of 2, okay? So then PEMDAS still applies, order of operations. So parentheses, work with simplifying all that first. So G of 2, if I evaluate that, that's inserting 2 in for x into the G function. So I'd have 1 over 2 minus 1. Also known as, if I do the arithmetic, it would be 1 divided by 1, also known as 1, if I simplify. Okay, and now I take this 1 and substitute it into the f function. So this would be 3 times 1 plus 4, also known as 7. Okay, let's do another example. G of f of -3. Again, by definition, this is saying g, and then in the g function, you're doing f of -3. Okay, so let's do this calculation. G, and then f of -3 would be 3 times -3 plus 4, right? I'm putting -3 in for x into the f function. Doing the calculation, this is -9. -9 plus 4 would be -5. And then this is saying in the g function now, put -5 in for x. So this is 1 over -5 minus 1, also known as -6, so -1/6, okay? And that's as far as we can go. All right. Next example, okay, we're doing the composition and finding its domain. So this is kind of useful. Again, for its domain, I end up finding this first and then going from there. So it's actually helpful to do the algebra first. So f of g, fog, of x, this is equal to f of g of x, right? And so f and then g of x is 1 over x minus 1. Okay. And then this is saying in place of x, insert the 1 over x minus 1. So I have 3 times, 1 divided by x minus 1 plus 4. Okay. Simplifying it, let's see. This is 3 over 1, so then I would just multiply numerators, multiply denominators. Do not need a common denominator since I'm multiplying. 3 over x minus 1 plus 4, and that is as simplified as it can get. Yeah, I could find a common denominator. Not going to do it. Okay, so I found f of g of x. Okay, now for the domain, right, I need two things. Okay, I need to figure out domain of g. Okay, domain of g was just all real numbers except 1. Okay, 1 would have made the denominator 0. And then I look at the domain of the output. Okay, when is this thing undefined? Okay, so to find that, let's see, in here, I'm just going to say that x, let's see, this one, 4 doesn't have anything. I don't have to worry about it. For this extra bit, x cannot equal 1 as well. So then I'm just going to say for the domain of the composition, I'm going to have all real numbers except 1. Okay, this one is a little boring, but again, both of the domains match up, both the domain of G and the domain of the output, right? Both of those are undefined at 1 and defined everywhere else, so it makes sense that the domain of the composition is just that. Okay, G of F, this one's going to be a little bit more interesting. Okay, again, we're going to do the algebra first. So G of F of x is equal to G of F of x, right? Okay, so then this is equal to G of 3x plus 4, right? Yep, 3x plus 4. Okay, and then this is going to go into the G function, so 1 over, and then it was x, 3x plus 4 plus 1. Okay, so then this is equal to 1 over 3x plus 5. Okay, now for the domain, right? Domain, I need to look at each one of these independently. So domain of f, okay? There's no denominators, there's no square roots. Okay, so then the domain of f is all real numbers. Okay, now I'm going to look at the domain of the output. And I should actually probably use this language a little bit more than, what did I say up here? Domain of f of g, let's change that to domain of the output. Okay, so I'm going to look at the output of this composed function. Okay, and in this thing, right, I have to have all x's such that 3x plus 5 cannot equal 0. So then if I solve this, right, move the 5 over and divide, I get negative 5/3. So then the domain of the output is all real numbers except negative 5/3. Okay, so now for the domain of the composition, G of F of x, right, I need to intersect these two, okay? And again, if you need to think on a number line, okay, so I would literally have, so this is 0, right? And for 1, I'd have the entire real line, and then at negative 5/3, for the other one, I'd have a whole, but otherwise all real numbers. So then I need to look for everything that they have in common, which is all real numbers, so except for negative 5/3. So negative infinity to negative 5/3, union negative 5/3 to infinity, which I am expressing in interval notation just for a little change of pace. Okay, so first with this, I wanted to point out that yes, to find the domain, it is a little different. Okay, they're not always the same as in the first one that we did with the domain. It happened to be the same just because of how it was constructed, but it need not be the same. Okay, all real numbers and then all real numbers except negative 5/3. The other thing that I want you to notice is that the order of the composition matters, right? We get completely different functions depending on the order that we compose functions in. Okay, so don't automatically assume if you do one direction, it's the same as the other. Okay, and on that same note, their domains are going to be different too. So be aware of that. Okay, but for domains, again, find the domain of the inside function, intersect that with the domain of the output, and you'll get your domain of the composed function.